Hey guys, my name is Jim Ferguson and I'm a PhD candidate in physics here at Texas A&M University. And I'm from a very small town called Hyco, Texas. I graduated high school from there in 1998. I came to Texas A&M University with the Naval ROTC scholarship. I earned a BS in nuclear engineering and a BA in physics. I hadn't anticipated studying physics originally, but I found that I was so fascinated with it that I couldn't help but be interested in it and study it. So I applied to graduate school here at Texas A&M University again, and I've come back and been here for 3 years now studying physics, and I love it. I knew I originally liked physics, namely because I love mathematics. I think math is great. And so now that's what I'm doing here at Texas A&M University, and I'm tackling some of the most fundamental problems physics has to offer. Another thing I end up studying due to gravity are something called black holes. And black holes are simply fascinating objects. Could you ever touch a black hole? What if you go into a black hole? What would that be like? What if your friend watched you go into a black hole? Could they see that? Would they ever know you went into the black hole? What in the world do I want to do with this? Well, honestly, I would like to teach at the college level, somewhere like Blinn or Texas A&M University or somewhere in another state. My wife and I actually threatened my in-laws with moving to Europe and teaching there somewhere. We think that would be wonderful to be in Europe and teaching. Another possibility is there are a lot of research labs. You may have heard of Sandia or Los Alamos. Maybe you've heard of Bell Labs, where AT&T was created. Texas Instruments or National Instruments. Some of your TVs were developed there. Sprint, Sanyo, AT&T again, all those places that design your cell phones, all those places have physicists working there, and they can do that. And it's an incredible job to do. So I wanted to take some time to show you and explain a little bit about the work I do. And I'm going to try and keep it at a really basic level. And so my wife reminded me that a long time ago she gave me a Slinky. And this is a really cool toy. And physicists at heart are really children, and we like toys, especially a Slinky. I mean, this thing is really cool. And so we thought of some nice things to do outside, and we're going to take this outside with us and explain a little bit about geometry and black holes and string theory, at least what we thought was fun. So come on outside with us. And another cool thing about black holes is that if you look at them in 5 dimensions instead of 4, you get something called a black ring, as opposed to just a black hole. And so now you have the standard 3-dimensional sphere that you're used to thinking about, but added onto that is something called a torus, or a circle, but you get a black ring. And so you can imagine connecting these 2 ends, and now you have what looks like a donut. We call that a torus in mathematics. And you know that the inside of this is hollow. And so you can imagine that the outside and this inside circle here are solid and hollow on the inside. So it's a hollow donut. Now what would happen if light got trapped inside of this donut or inside of this torus? Could it ever get out? And that's the point of a black hole in 5 dimensions. That light would never escape. And so it's a black ring now. It's the same thing as our black hole in 3 dimensions or 4 dimensions, except that was where we had a sphere and the light couldn't escape the sphere. Now, your light is trapped inside the black ring, and the same thing. Once it gets inside here, it can't get out. It's impossible. And that's really cool. Now, does that exist in reality? Well, probably not. We recognize that. But it's a really fun solution, and we enjoy it. And that's the point of mathematics, and this is part of the creativity. You're not bound by the normal things you see in life. You can study all the normal things. I can explain why this grass falls straight down. There was no wind, so it didn't move in a different direction. It obeyed gravity and dropped straight down. It'll do it again. And you can do that 17 times. And the grass will always fall straight down. It doesn't run away somewhere else. It does what it's supposed to. But what if you only went to a 2-dimensional surface and started looking at gravity there? Or what if you went to a 10-dimensional surface and studied it there? How would gravity change? And that's really cool. What if you went to a surface which doesn't look like anything we've ever seen? You could only write it on paper. And you had to obey the mathematics behind it to study what gravity looks like on that surface. And that's what I really enjoy and what I get a kick out of. And so you have to study a lot of geometry, so that's a good bit of mathematics. You have to understand some fundamental principles of gravity, and physics most especially. And gravity affects everything. From the So in string theory, right now we're using the slinky as our model for string theory. And as we start shaking it in a second like this, you can see that's one mode of oscillation, and it's the primary mode. And so this would be one particle in string theory, and it would be its own particular type of particle, and that would be it. And it'd be a rather low energy particle. However, if you wanted to look at a different particle, then you would just go to another mode of oscillation. And so maybe you'd go to something that looks like this, where you have one bouncing up and one bouncing down at the same time. And so this would be a second different particle in string theory. It has a different mode of oscillation, and that's it. And it might be a slightly higher energy particle. And if you wanted to look at the next higher energy particle, then you would do the same thing and just create one more peak inside of the string. And so you would see something that looks more like this, perhaps. And so you can see, now you've got 3 peaks, and this would just be a third type of particle in string theory. And you can imagine 5 peaks and 7 peaks, and any number of peaks. And that's the point of string theory is, now you have all of those peaks represented by one single string, and so multiple different particles from the same model. And that's the really cool thing about string theory. Now that's a really basic level idea of it, but that's the fundamental idea. And so I'm looking forward to this year your questions. And the most important question I'm actually looking forward to, what I'm interested in hearing is, hey guys, I wanted to take a second to introduce you to my house. My wife is at work right now, and so I'm filming this myself, and so I'll be behind the camera. This is the front porch area. My wife and I like to spend quite a bit of time out here just sitting, talking, reading, talking to our neighbors as they walk by in the evenings, and obviously we like to flower and garden a little bit. Hey guys, so I wanted to introduce you to two of my two dogs, and these are my babies. This is Allie right here with me, and she loves attention a lot, and this is Maggie. Let's go inside. And they are really good dogs. They love Daddy's attention. Coming into my office, and this is where I spend rather a lot of my time. I have a lot of books, as you can see. This is my dry erase board, and when I'm sitting at this table or sitting in this chair working, I'll come somewhere in a book or in a paper and realize I don't understand what you're talking about. And I will get frustrated, and I will come to the board and start writing and try and figure out if I can understand their method. And normally I can get around to it, and if I can't, then I will wait and go to my advisor and see if he understands it. And there have been a few times where I've gone to my advisor and talked to him, and even he says, well, we've not understood this person, and so we move on with it, and that's acceptable. So the other thing I wanted to show y'all that's really important in my life is not my car, but my bike. We're in Austin. We got the sun shining down on us. It's not a hot day or anything, just a melted bar to chew on. It's a Cliff Bar. Good stuff. We just got our 6th out of 8 obstacles and our first mystery point, so that was really cool. We're freaking tired at this point. It's kind of nice. But anyway, look forward to seeing you guys soon, and so have a good time. It's a fun day Sunday in Austin. Enjoy. Hey guys, this is Mr. Ferry. He's our first checkpoint mystery point. He's got a few encouraging words for y'all.
Ride hard and ride well.
Ride hard and ride well, amen! Yeah! Thank you, Mr. Ferry. That's us running.
That's us like kind of not well, really.
It's an arch. It's an arch.
Oh, yeah. Oh, man. Now, there's the idea. Through the head.
I wish we had little microchip things. Okay!
And we're running. Okay. There we are right there anyway.
Yep. Right here. Okay.
You got it. Woo! Nice!
Yeah!
Alright, first try. And here it goes.
That's exactly it. There you go.
Head down.
Are you okay?
That could have been much worse.
I didn't actually get that on camera. I just heard it. Woo! Good job! Yeah.
So in closing, I'm really looking forward to getting to see you guys this year and getting to meet you. Spend an hour and a half with you, I think every Tuesday, and work with Miss Marburger to teach you some really cool math and some really cool science.